All right, so several ways to graph these. You can use your graphing calculator to graph them like piece by piece here. I'm just going to quickly sketch them by hand based on the shifts. So when I look at this first one, I've got two different graphs that will take place on this function, and they're just going to be pieces of those graphs, right? So this first one is absolute value. So absolute value parent function looks like a V, so it's going to be that V at 0, 0, right? But what direction is this shifting? Left 3, down 1. So I'm going to take that V, and I'm going to shift it left 3, down 1, and this is going to be the V here. You're just sketching it. So if X is less than 0, that means that I'm taking this up here. I'm going to stop at this point right here. Okay, now actually that is definitely a little too high here. It should be down here, but we're just sketching. The rate of change should have been a little different, so it really should have been about here where it crosses. Mine's a little more, but you're just sketching, so that's fine. So you can see that it's this part of the graph, right? And then we're looking at the next one, which is linear. So 2x minus 5, so that is going to be a line, right? And we know that it's always going up this way. So, but I'm going to go down 5, so 1, 2, 3, 4, 5, and I'm going to make my intercept, and then we're going to make our graph from here. So you can do your rise over run pretty quickly up to right 1. You can also just sketch it. And this one is only this half of the graph because, it's x is greater than or equal to 0, right? So it's just this right half of the graph. All right, and I'm done. Now, the only thing here is to make sure that you understand that this really is a little lower. I just did a quick sketch of it, so if you do it in your calculator, it should actually be down here. So I'm going to actually just kind of correct that. It should look sort of like this instead. Okay, so just note that this is a sketch. Just I don't want you guys to be confused. Okay, so what's the domain? Well, this goes to the left to infinity, and then it stops here, and there is a hole, but this is a jump, right? There's actually this point on the graph as well. So it's actually going to be all real numbers. Now, if this was open circle here, then it would definitely be, this point would not be on the graph, right? But that's not the case. So let's look at the range now. So what happens with the range? Well, it goes infinitely forever, right? But does it go down forever? No, it actually stops here. So y is actually greater than, let me move this down here. This is all real numbers. The range is y is greater than or equal to -5 because everything is greater than or equal to -5. Discontinuities, well, this one has a jump. And where is that jump? It's when x equals 0. You could try to name it by the y as well, but there's two different places here, so I would just definitely stick with the x. It's usually easier when you're naming those jumps. All right, let's look at one more together. We'll do that was number 3. We'll do number 5 on the next page. Okay, so number 5, we are going to, I'll use the calculator for this one so you guys can see. Okay, so let's graph both of these separate. 4 over x plus 3. So 4 over x plus 3. Sorry guys, this is very hard to do while I'm videoing as well. Okay, graph this. So I see that it's the rational function, which makes sense, right? Remember this is how rational looks. So the one thing is x is less than or equal to 1. So it's only going to be from here and then moving on this side of the graph. Okay, so let's just get a couple table values here. That's going to be a little easier to sketch. So I know that it's x is less than or equal to 1. So there's no point in me even getting all these points loaded in that. So let's get the point for 1. So I see that I have 1, 1. So I have x, y. I've got 1, 1. All right, and then let's see another point that's less than 1. Well, I don't want to use 0 because that's the decimal. Let's just use -1, 2. And let's see, let's use -2, 4. We'll get one more. -4, -4. All right, now one thing you'll note here is that it says error at -3. What takes place at -3? That's your asymptote, okay? Why is there an asymptote at -3? Well, when I look at the denominator, I know x cannot be -3, right? So x cannot be -3. Even though that falls within these conditions, there's an asymptote that takes place there. So let's just sketch these so we can see. So 1, 1. So I've got 1, 1, -1, 2, and -2, 4, and then -4, -4. And we know there's a asymptote at 3. All right, so we've got 1/2 here. Now it says equal to, so I'm gonna leave that as a closed dot. If it just was less than, it would be open. And then same thing here, I'm gonna have, this is gonna go something like this. All right, cool. So now let's look at the second one. So the second one says 2x minus 7 if x is greater than 1. Well, I know this is linear, right? So I'm gonna go down 7 and make my first point. 1, 2, 3, 4, 5, 6, 7. I'll make my first point here. And this is when x is greater than 1. So the problem is this is actually 0, right? So that's actually not going to be a part of my graph. And this isn't either because it's greater than 1. So rise over run. So this is actually going to be the first point on the graph. This would be an open circle there. And then this graph will continue going this way. Okay, so even though this is the y-intercept, I can't include this in the graph because it doesn't start until it's greater than 1. It doesn't have 0 included in this domain. All right, so now let's figure out what is the domain of this graph. Okay, well, the domain here is going to be -infinity to infinity, but what happens right here at -3? Nothing ever crosses, so the domain is all real numbers except x cannot be -3. All right, what about the range? Well, it goes down forever. I do see a hole here, but it's a jump, so that actually is a part of this whole domain. So it goes down forever and up forever, so the range is actually all real numbers. All right, and what about discontinuities? Well, I've got an asymptote here, so we call that infinite. And where is it infinite? At -3. And then we have a jump. And where is there a jump? At x equals 1. All right, so from there, you should be able to sketch those graphs. They don't need to be perfect graphs. If you want to use your calculator, you can to get those points. But you're really just making sure you can find the domain, the range, and then the holes, jumps, all those discontinuities. All right, so go ahead and work through all of the problems we didn't get to. It should just be the evens on this page. And then if you'd like some extra practice, there's independent practice on the next page. Email me if you have any questions or come by office hours.